Okay, so very good afternoon. Yeah, very good afternoon. This is Balaji here from Virtual Tech Services. Audible then. Okay, so from morning I have seen the topic is going on supply chain management. So I'm going to take about AI driven supply chain simulation, the future of resilience. So how the AI makes an impact in the supply chain management.
offer practical insights and valuable takeaways for all participants. Now, I request Dr. M. Vidyashree, ME PhD, to deliver the introduction about our chief guest. Good afternoon. It's my immense pleasure to welcome you all to this event on behalf of our department, Artificial Intelligence and Data Science. We are honored to have with us Mr. P.Balaji, a seasoned professional with over 14 years of experience in software development and team leadership, currently serving as Senior Development Manager at Virtual Tech Chennai. Mr. Balaji embarked on a professional journey after completing his undergraduate degree in computer science. Over the years, he has built a robust career spanning areas such as full stack development, architecture design, and delivery management across diverse industry domains. Since joining Virtual Tech, he has excelled in leading cross-functional development team, architecting scalable solutions, and aligning technology strategies with our organizational goals. His expertise encompasses agile methodologies, cloud native applications, and DevOps practices, delivering high impact projects with precision and quality. A recognized mentor and leader, Mr. Balaji consistently fosters professional growth within his teams, promoting knowledge, sharing, and innovation. He has delivered several internal technical sessions and workshops aimed with upskilling colleagues and in introducing best practices in software engineering. Please join me in welcoming Mr. Balaji, whose dedication to technology and excellence leadership will undoubtedly enhance today's event. We welcome you, sir. Without any further delay, we now hand over the session to our honored speaker. Dear participants, let us stay focused and make the most of the valuable learning opportunity.
So, very good afternoon. So the session is about like AI-driven supply chain simulations, which is the future of resilience. So basically, like from the morning, we have seen like how AI is impacting in the supply chain management, and supply chain is one of the major department in any of the industry, as we know that, right? And when we are integrating the artificial intelligence in that, so which can revolutionize the planning, production, management, and optimization of the activities, and by processing the vast amounts of the data we can predict the trends and we can perform the tasks as well in the real time, and it can also improve the decision makings what we make using the AI. So basically if we see the trends like global supply chain management market basically projected to reach around $37.4 billion by 2027, and with the integration of the artificial intelligence we can expect to save around $1.3 trillion in logistics by 2030. So this transformation is very much important for navigating the complex and also for the global markets as well. And let's have intro like how the AI can help in the supply chain. Like basically, supply chain is about like moving the things from one place to another place, and it's all about the logistics and for demand forecasting and all the things what we can say. Like basically, if we say like to maintain a business, to run a business very smoothly, to monitor the business and to get a growth in the business also, we need supply chain management is one of the main process in any of the company. So here the AI can keep all parts of supply chain in the balance with its ability. Oh, sorry. So basically, AI can keep all parts of the supply chain in balance with its ability to find the patterns and relationship, unlike a traditional non-AI system. Because as you know, like the main strength of the AI is in the pattern recognition only, and more of the things nowadays, like more of the applications or as more of the websites, whatever is going through now, are everything are based on the artificial intelligence only. Like these are analyzing the patterns of usage behaviors or patterns. So based on that only, Amazon is working, Flipkart is working, even Zomato and Swiggy, and this one Instagram algorithms, YouTube algorithms. It works on the similar way. So these algorithms, they are making use of the user behavior. They're taking our data, and by using those data only, they are getting us the personalized recommendations. So in this place, that is AI patterns can help us to optimize the logistic networks, that is from the warehouse to the cargo freighters to the distribution centers, and it can suggest the shortest path for possible by keeping a track on the like what is it by keeping a track on the live data. And as well as it can also offer assistance in the forecasting as well, such as like how much demand is being planned, and whether the company is being able to predict the productions or to plan for the warehouse capacity. So previously, like if by uh, like when a company used to plan for any other process to launch some new product and all, so at that time they were not having much resources for going through. But nowadays, like we have the this AI thing, so that we can just plan the demand, like how much demand is there for this particular product, and how can we plan for the productions, and how can we plan for the capacities. That is how much demand may be arise, so that we can plan the capacities of the warehouses as per the trends. And some of the AIs are also there, which will gain insights from broader data by using the data from the Internet of Things, that is IoT, which is deployed across the supply chain. And the next usage of AI will be in the tracking the inventory levels and the market trends. So by tracking the inventory levels and the market trends, it will be easier for the companies to check up what the trends, like what product are going on in the near future. So what product will be there in the real time. So what product will be like what to say, like what changes we have to do in the product to meet the customer demand. So we have many live data, as you can see, like many automobile companies. So previously they were having very down trends because of the designings and because of the low market strength. But nowadays they're coming with more designings. As you can see, like most of the companies, automobile companies, are mainly focusing on the designings, and as well as on the features what they're providing in the cars. So because of that, the companies are able to make the trends. That is, they can be able to maintain the trends. And in the next one, we can say like AI can help us with transparency for the manufacturer, and also to provide the valuable data for all the stakeholders in the supply chain. And by using the AI over there in the supply chain management, so it can offer the unmatched time, and also it will save the costings also. And it will also help the companies to meet the ethical and sustainability standards, which have historically very time consuming and expensive task for that. So we can see like AI is there, like from like identifying of the patterns to the forecasting to the demand, to the tracking the inventory and tagging the marketing trends to the by checking the logistics routes as well. So all those things are possible using the AI in this for the supply chain management. So, as we know, like the growing complexity of the supply chain is in the volatility, inefficiency, uncertainty, and risk. So, volatility, as we can see, like global disruptions are happening, such as 2021, that canal blockage and COVID-19 pandemics, and after that, like many recent trends are happening. Because of that, there is a like there is a market instability. That is, we can't say like market is too much stable for these things now. And next, inefficiency. So because of the inefficiency, the companies are incurring around 15 to 20% of this inventory value by holding the annual holding cost, and because of that they are unable to maintain the certain stocks as well. And next is uncertainty. So since there is a annual demand fluctuations of up to 40%, so the companies are not able to uh, uh, like maintain their stocks. So since they're not able to make the accurate forecasting, so it is difficult for them to make the plannings as well. And finally, the risk. The staggering 70% of the companies experiencing at least one significant supply chain disruptions annually, which is underscoring the vulnerabilities. So the AI driven simulations. So AI driven simulators are something like which can be used in the cutting edge technologies to create the dynamic and virtual replica of the physical supply chain, allowing for unprecedented analysis and optimization. So the first one is the digital twin technology. So in the digital twin technology, it will replicate the entire physical supply chain from manufacturing to the delivery. And this technology is being offered by Amazon. We have this technology in Azure as well. So some of the companies, Siemens, so some of the companies in the market who are offering the digital twin technology, who are ready and who are helping for us to replicate the entire physical supply chain managements from manufacturing to delivery, so that the companies will be able to forecast like what product would be better for the demand forecast, and what product will be better for them to bring it in the market. And next, in the machine learning, it will analyze like around historical data points to identify the patterns and to predict the future outcomes, like what type of products, like what type of demands may arise, and what type of products the customers, the clients are expecting. Next is the reinforcement learning. So means reinforcement learning is basically based on the feedbacks, that is continuously optimizes the decisions regarding the logistics, inventory, and production under dynamic certain conditions based on the feedbacks. So whatever feedbacks the data are getting, so whatever feedbacks the system is getting, based on the feedback, the machine will start learning, and it will make some fine tuning in its system and get the data properly. And finally, the rapid scenario testings, which will simulate millions of potential scenarios in minutes, a process that would take weeks or months with traditional methods. So the process of a longer duration, that is which may take weeks and months, so that type of scenarios we can finish within some minutes. So that is what the AI driven simulations will work. And the core AI technologies which will enable simulations are the predictive analytics. So predictive analytics. So this will improve the demand forecasting accuracy by 10 to 15% by reducing the stockouts and overstock situations. And we have reinforcement learning, which will optimize the complex decisions like dynamic routing, inventory levels, and production scheduling. And as I said, like digital twin, this is one of the latest and very informative technology, which will create a real-time replica of the supply chain, and what are the scenarios are possible we can make up in this. And finally, we have the prescriptive analytics, which can provide an actionable recommendations for solving the complex supply chain challenges and optimizing the performances. So while implementing the AI simulation, the key considerations are: the first one is the data integration. That is, we should have a proper data for that, a proper labeled data or else like unlabeled data, whatever data we are using. So the data should be very much proper for us. So it should be unifying disparate data from ERP, WMS or the CRM systems into a single cohesive platform, which is very much essential for the comprehensive analysis. And next we need to see about the model training. So for training the model, we should have a proper algorithms. Uh, we should build the models. We should build the predictive and prescriptive models. Uh, 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 which demand the large volumes of the clean, high quality, and historical and real time data, so that, uh, as you know, like AI and machine learning, everything depends on the data only. So, as much clean data we have, that much of pure accuracy we can expect in these models. Next is scalability. The simulation system must be designed to adapt and expand with the growing complexity and size of the supply chain network. So simulation there will not be much issue, but when we are going to the real-time simulations or real-time scenarios, then we need definitely need a large number of data, a large number of uh, data we should be able to cope up with the growing complexities. And next to the expertise. So the effective implementation and ongoing management, everything requires a strong collaboration between the supply chain domain experts and the data scientists. So then only the companies can be able to predict the demand forecasting. The company will be able to predict the customer segmentations, customer demands. So everything can be checked using this by using the simulations. And we have some real world impacts like in the Amazon. So we have some companies here, Amazon, Walmart, Intel, and Siemens, who are using these technologies to cope up with their supply chain demands. So Amazon is utilizing the AI for the high efficient package sorting and optimal routing, and also for the automated warehouse optimization, which streamlines its vast logistic network. Because Amazon, as you know, like they have a large customer base, and every day they will be having some numerous number of orders, some numerous number of deliveries. So these deliveries, like if they do it manually, so this will be very much difficult to scale to manage the data as well. So they are making use of the artificial intelligence for basically for the sorting of the packages as per the data what they're getting, and for the optimal routing as well, and finally to automate the various optimizations. And next, the Walmart is using the ML for precising the demand forecasting, so which has resulted in the 60% reduction in their food waste across its stores. So next is Sintel. The Sintel is simulating the complex manufacturing process to identify the inefficiencies and to improve the production's yield by 5%, enhancing the output and the quality. And finally, the Siemens. So Siemens is leveraging the digital twin technology. As I said, now, like we have the digital twin technology available with Siemens, Amazon, Azure, and some of more companies. And so one of them is Siemens. So Siemens is using this digital twin technology to reduce the time to market for the new products by an impressive 20% accelerating innovation and delivery. So we have a real-time a case study here. So, for example, a scenario there is a cyber attack which causes the 14-day shutdown of the port of the Long Beach. So here we can see like we have a analysis of 10,000 pending import containers, identifies critical shipments. So the outcome will be like 3,500 critical shipments are immediately rerouted to alternative ports by using the artificial intelligence. Since artificial intelligence, it can find the shortest path and it can get the data very quickly. So with this benefit, the critical shipment delays were reduced by 60%. That is, the 4 weeks of the delay were came to the 1.6 weeks. And finally, in the cost saving, they had like 2.5 million dollars in the expedite air freight charges by avoiding the panic air shipments. So this is one of the scenario, and we have one more scenario like an unexpected 30% surge in air conditioner demand due to a prolonged heat wave. So in this simulation, we can see like a predicts optimal reorder points for 20 regional warehouses hourly, leveraging real-time sales data and weather forecast. And the outcome will be the inventory levels are adjusted dynamically by 25% across the entire supply networks. So the main benefit will be reducing of the stockouts by 85% compared to the traditional static planning models, ensuring the product availability all the time whenever the demand arises. And return on investment, so captured $1.8 million in incremental sales during the peak season by meeting the customer demands effectively. So they planned as per the customer demand, and as per the demand they have, the company can be able to maintain the stocks as well. Okay, so now we have hands-on project here for the customer segmentation recommendation system. So we have a data of online retail. Right? We have a data of online retail, so which we have taken from this website, Archive ICS UCI Edu. So this website belongs to UC Irvine Machine Learning Repository. So we have many data sets here. So we have taken this data set specifically for the customer segmentation. So basically, I just want to check like what products are there from, like what products are in demand, so that the company can be able to uh, plan the products, the manufacturing as per the demand. So here we are taking the data from here, the online retail, the data set information. So this is a transactional data set which contains all the transactions occurring between 2010 and 2011 for a UK based and registered non-store online retail. So the company mainly sells the unique all-occasion gifts. Many customers are company or many customers are the wholesalers. So we can see like we have a variable name as invoice number, stock code, description, quantity, invoice rate, unit price, customer ID, and country. So we'll see about this when we go for um, the project. Yeah. So, so in this project, we are going deep into the sector of the online retail by analyzing the transactional data set from a UK-based retailer available at the UCA machine learning repository. So, in this data set, as I said, like we have data from 2010 and 11. So, our main objective is to amplify the efficiency of the marketing strategies and to boost the sales through the customer segmentation. And our aim is to transform the transactional data into a customer centric data set by creating new features that will facilitate the segmentations of the customer into the distinct groups using the k-means clustering algorithm. So this will also allow us to understand the distinct profiles and preferences of different customer groups. By using this, we can develop a recommended system that will suggest top selling products to the customers within each segment who haven't purchased those items yet. Ultimately, it will enhance the marketing efficiency and foster the increased sales. So, these are our objectives. So, first of all, what we have to do, we have to use the data cleaning and transformation. So, in this part, we'll clean the data sets by handling the missing values, duplicate values, and outliers, and we'll prepare it for the effective clustering. And then we have feature engineering, in which we develop new features based on the transactional data to create a customer centric data set, setting the foundation of the customer segmentation. And next we have a step called pre-processing. So pre-processing is basically for pre-process the data. That is to undertake the featured scalings and dimensionality reductions to streamline the data. This will enhance the efficiency of the clustering process. And next we have customer segmentation using k-means clustering. So segment the customer into distinct groups using k-means clustering. K-means clustering, which will facilitate the target marketing and the personalized strategies as well. And next we have a cluster analysis and evaluation. So the analyze and profiling of each cluster to develop a targeted marketing strategies and to access the quality of the clusters formed. And finally, in the recommended system, what we are going to do is we are going to implement a system to recommend the best selling products to the customer within the same cluster who haven't purchased those products yet. So here we can see we are importing the necessary library. We have NumPy, Pandas, Cpon, Matplot, like PyPlot, Matplot, like GitSpec, Plotly. So Plotly will get us interactive graphs. So Matplotlib is a library for the graph plotting, and in the same way we have a Plotly also. But difference with the Plotly, the graph will be more interactive. Next, we're importing this one. linear segment color map, we have M colors, linear regression, we have isolation forest, we have standard scalar, we have PCA, we have elbow visualizer, and then we have sit out scope. So all those stuffs are available over here. So from Plotly offline, we're importing the INIT, initializing the network mode, and we are connected. It's true. So here, what we are doing is we are configuring the C1 plot style. So here, first of all, we are loading the data set here. So in the data set, as we can see, put the print, put a print here. Okay, so we are printing a print here. So after printing the data set, as we can see, we have over 5,41,908 data here in this total data set. So um, the column names are invoice number, stock code, description, quantity, then invoice date, unit price, customer ID, and the country here. So all those things are there. So in the invoice number, so in the invoice number, it will represent each unit transactions. So if the code see, it indicates the cancellation. And next in the stock code, this will uniquely assign to the each distinct product, and description will have the description of each product. Quantity will have the number of goods of the products during the transaction, and we have the invoice date, the date and time of the transaction. And next we have unit price. The unit price of the product is sterling. And next we have a customer ID. This is the identifier uniquely assigned to each customer, and the country of the customer. So this is the description of the data set. Okay. So since this is a hands-on session, so I'm just sharing the dataset link in the group here. So this is the dataset link. You can download the dataset from here, and I'm also sharing the major libraries what we need to import here. So you can just copy this one, and you can just try it in your system. So I have shared the basic library code here, and I have also shared the Plotly code also, which we are going to use in our notebook. So the Plotly, since it's a interactive data set, sorry, interactive graph building, I will show you when it will come. So please download the data set first, and just import the libraries. Then we'll go for the next step. So you should go to this website. From this website, you can simply download this data set, and you can keep the data set in please data.csv, or else I will share the data set as well. Yeah, I have also shared the data set in the group. I have also shared the data set in the group. You can simply download the data set from here, and you can use in the project. So I am sharing code one by one. I will explain the code and will share the code one by one so that you can parallelly run the code along with me. If any doubt, if any clarifications, you can raise. Thank you so much. You can run this in the Jupyter notebook. You please check the libraries. If it asks for any libraries to install, you can install the library using pip install. Is it done? Any queries up to here? Are you getting all the libraries? I have shared the code in the group for this library import. I have shared the library import code in the group. So also I have shared the data set over there, so that you can simply download the data set from the group. And after downloading the data set, just create a folder. Okay, just create a folder here, like by going this new folder, create a folder. Inside that folder, keep both your files in a single folder. That is your customer segmentation file and also the data. These both should be in a single folder, so then only it will be easier for you to call the code. Or by suppose if you are having your data somewhere in your system, you can simply call the path as well. If you're having any difficulty for calling the data, calling the paths, you can just let me know. Is it coming? Any doubts up to here? So I have shared the dataset description also in this. Okay, so after doing this, we are going for the data pre-processing. So here we are just looking on the 10 datas, like we are calling like df.head. So my datas are stored in the df. So df is my variable in which I'm calling I'm storing my data by calling a function from the pandas read underscore csv. So I'm calling data.csv is my folder. So I'm not calling it using the path. And then we have encoding of ISO 88591, and then we're printing the df here. So these are the values I'm getting from the df, and I have already said about the dataset descriptions. So then next we're initializing the data analysis. So here we're performing the preliminary analysis to understand the structure and the type of the data columns. So we have seen like what are the data are available. So here we are using the head df dot head here. So simply like if we are using the head alone, we'll be getting the five datas only. But students to look for the more data, I'm just giving it 10 here. So in this 10, I can see like I have the invoice number, stock code, and we have the description of the product. So we can see like products we are having as white hanging heart, tea light holder, white metal lantern. So this data set, particularly as we said, like this is a gift data set. So hand warmer, assorted color bud ornaments, cluster, frosted tea light holder, and we have the quantities as well, and we have the invoice date, we have the unit price, and we have a customer ID and the country of the sale. So this is the United Kingdom data, that is UK data, and we have all the data available here. And next in the info part, so in the info part we can see uh, like basically for using the info part, the thing is like we should know like what datas are object, what datas are integer, what datas are belong to the float, so that we can be able to analyze the data, we can be able to go through like what type of plottings we can plan on those data. So here from the invoice number we can see like this is the object data type which contains the invoice number for each transactions, and each invoice number can represent the multiple items purchased in a single transaction, right? So that is what we can know using the invoice number. And next in the stock code we can see like an object data type column which represents the project code of each item, and descriptions. So in this column also is a data type as object, so which contains the descriptions of the products. So it has some missing values with 5,40,455 non-null data here entries out of 5,41,909 data. And next we have a quantity here. The quantity we are mentioning in the integer column. So this indicates the quantity of the products purchased in the each transaction. And next we have an invoice date, a date time column basically, which indicates the records of the date and time of each transaction. Next we have a unit price. So in the unit price also is a float column which represents the unit price of each product. And next we have a customer ID, which also is a float data type. So the customer ID is basically it contains the customer ID of each transaction. It has significant number of missing values as well. So that with only 4,06,829 data are having non-null entries here. And finally we have a country. So in the country all the data are object only. Right. So from this overview, we can see like there are missing values in description. So we can see like only in the description in all the other columns we have the data available, but only in the description and customer ID. Only in the description and the customer ID we have the missing values which need to be addressed. And the invoice date column, yeah, the invoice column is already in the date time format, so which will help us in the time series data analysis. So yeah, I'm just sharing the code parallelly. These are the pre-processing codes only. Okay, I'm just sharing the codes parallelly here. Next, we are using a describe function. So describe function will tell about account, mean value, standard value, minimum value, 25% of the data, 50% of the data, and 70% of the data with the maximum of the data. So we are taking three columns here: quantity, unit price, and customer ID. So these are basically used for the numerical calculations. I'm just sharing the code over here. Have you done with the library imports? Have you done with the library imports and dataset imports? Any doubts in that? Do you have any doubts in that? You can put a text in case if you're having any doubt. So next we're getting a summary statistics for categorical variable. So from this data, so summary statistics will tell about a detailed overview of the data set. So here we can see how we can inference here is the quantity. The average quantity of the products in a transaction is approximately 9.55 as we got here, right? So 9.55. So the quantity has a wide range with a minimum value of minus 80,995 to 95. The negative values indicate that returned or cancelled orders which need to be handled very appropriately. And next, the standard deviation is quite large, indicates the significant spread in the data. The presence of the outliers is indicating a large difference between the maximum and the 75th percentile of the values. And next, in the unit price, as we can see here, in the unit price, the average unit price of the product is approximately 4.61. As you can see here, 4.61 is the average unit price of my product, and the unit price also shows a wide range from minus 11,062.06 to 38,970, which suggests the presence of errors or noise in the data. Similar to the quantity column, again the presence of outliers it is indicates by a large difference between the maximum and the 70 percentile. Okay, next we have a customer ID. So in the customer ID, you can see like we have 44 lakh 66,829 non-null entries, which indicates the missing values as well. The missing values in the data set
ஒரு
which
நாளைக்கு
needs
ஒரு
to be
கேண்டிடேட்
addressed.
எத்தனை பேப்பர் திருத்தலாம்?
And the customer ID range is from minus sorry is range from 184 to
கொடுத்துருக்காங்க, நான்
182
5 6
87. So that is the range what we
ஏன்னா
are
அந்த
getting in
11
this.
பேப்பர் இருக்குல்ல நம்ம எழுதிருக்கோம், அதில் கவுண்ட் பாருங்க. இந்த 11 பேப்பரை 7 வருது. வேறு வழி இல்லை, ஒரு ஆள் கொடுத்துதான். அதனால தான் கேட்டேன், ஒரு நாளைக்கு எவ்வளோ திருத்தலாம். இப்போ 7 பேப்பர் திருத்தலாம், 57 போடலாமா? மேக்ஸிமம் வேறு வழி இல்லை, போட்டுதான். அதுக்கப்புறம் என்ன ஒன்று உசுரை யாரும் இதை பிரிக்கக்கூடாது. பிரிக்காமல் திருத்தணும்னா அப்படிதான்.
Okay, any doubts up to here? Are you getting any doubts up to here? Have you finished the library import everything? So in the invoice number, we can see we have a total count of 5 lakh 41,909, in which unique data is 25,900 data. So with this invoice number, we can see like it indicates the 25,900 unique transactions. That means separate transactions here. Yeah. So separate transaction here. So more. Okay, let's have a break of 10 minutes. Then we will continue the session.
Excuse me, we'll start the session.
Okay, so okay, so we have seen up to this summary statistics for categorical variables. So here we have taken DF to describe. We are including the object. So in this one we have got this invoice number, stock code description, invoice state and country. So we were looking on it one by one. Then we are going for the data cleaning and transformation. So in the data cleaning and transformation, the first part, what we're doing is we are handling the missing values. I'm just sending the code. Okay, we are handling the missing values. So for handling the missing values, the first thing what we are doing is to identify the null data, right? Like what are the data are null and what are the missing data are available. So we are checking those data first. Then we are getting the percentage of that by using the sorting of the values. So we are sorting the data in the ascending one, since we have mentioned it here as ascending is equal to 2. True. So we are ascending the data. Then we are plotting the bar horizontal graph. So we are mentioned as bar h on the AX. So we have a subplot of figures is 15 cross 4. So we are using this bar horizontal data, and after that we are annotating the values and the indices, and then we are setting the x-axis limit, and we are setting the title and x label. So this is our title, percentage of the missing values, and here we are getting the customer ID of 24.93%. So that is the customer ID column contains nearly a quarter of the missing data. So, and this column is very much essential for clustering the customers and to create the recommendation system. And by imputing such a large percentage of the missing values may introduce a significant bias or noise into the analysis. Moreover, since the clustering is based on the consumer behavior, customer behavior, and preferences, so it is very much crucial for us to have an accurate data on the customer identifier. Therefore, removing the rows with missing customer ID seems to be the most reasonable approach to maintain the integrity of the cluster. So, what we do, we'll remove this data, and next we have a description. So, we have only 0.27% of the missing values, so which is a very minor percent. And however, we can notice like there are inconsistencies in the data where the same stock code does not have always have the same descriptions. So this indicate data quality issues and potential errors. So by this by removing the rows with missing values in customer descriptions, so we aim to consider a cleaner and more reliable data set. So in this step, what we are doing is we are extracting the data of the customer ID and the description. I'm sharing the code here. Sharing the code one by one. You can just see I'm sharing the code one by one. You can just try the code. If you're getting any difficulties in running the code, you can just ping me in the group, or else you can just ping me in uh, Gmeet as well. So after that, after looking on the descriptions, we are just removing the rows and the description also of a customer ID and description, since we have already planned here. Like since we have the missing values of 24.93% as 0.27%. So we are simply removing the customer ID and description over here. And after the removal, we are verifying like still is there any missing values are present. So for verification, we are just using this tf.null sum of the sum. That is overall, it will tell us like uh, still is there any missing values are available. Now, after handling the missing values, now we are handling the duplicates. Right. So let's find the duplicates here. So find the duplicates. We are using the duplicated keyword here, and we are keeping all the instances. And after that, as usual, we are sorting the data here. We are duplicate role, we are sorting the data here, and finally we are printing the top 10 data after sorting it. So we can say we have some duplicate data here. So basically the presence of the completely identical rows, it includes identical transaction times, and which may suggest that these might be the data recording errors rather than a genuine repeated transactions. Therefore, I'm just uh, going to remove these duplicate values as well. So removing these rows will help us in achieving a cleaner data set. So for that purpose, let's first we are removing the duplicates. So df dot drop, we are dropping all the duplicated data here. So the data set contains 5225 duplicate rows which needs to be removed. So in this line I'm just removing the duplicate values here, and finally we are getting the number of the rows in the data frames. So it will tell us like 4 lakh 4 lakh 1604 rows are available in the dataset. Now let's treat the cancelled transactions. So now we are refining our understanding of the customer behavior and preferences. So we need to take up the transactions which were cancelled, because cancelled transactions are something like which need to be seen, like why the transactions has been cancelled, and why and what top and what sort of actions can be taken for those transactions, like for those cancelled transactions. So here we are taking a df transaction status. So in the numpy zone where invoice number of cancelled and completed. So we have a data of cancelled transactions, and we'll have a data of the transaction based on transaction status and customer ID. So here you can see we have a quantity and the unit price. Here we're again describing the data. So here we can see that all quantities in the cancelled transactions are negative here, which indicates like these are the indeed orders which were cancelled. And the unit price column has a considerable spread. It shows the variety of the products from the low to high value, and which is a part of the cancelled transaction. So basically, the handling of the cancelled transaction will enhance the clustering process by incorporating the patterns and trends observed in the cancelled data, so which might present. Okay, so which might represent the certain consumer behaviors and preferences. Okay, and it will also allow us to recommend a system to possibly prevent the suggesting products that have a high likelihood of being cancelled, so that the system should not process some products which may be cancelled. So thereby it will improve the quality of the recommendation. So it should not be happening something like that. We are ordering something in the Amazon. So after ordering, the okay. So which will allow us to recommend the systems for the product. So as I said, like it should not happen like we have ordered something in Amazon or Flipkart, and in that one, I suppose like after ordering, the orders are getting cancelled. So this will lead to the quality issues, and also lead to the company's name also will getting damaged. So here you can see like we can remove those products to avoid any type of any likelihood of being cancelled. So here we are finding the percentage of the cancelled transactions here. So we can see like the total percent of cancelled transaction, the data set is 2.21% only. Yeah, it's 2.21% only, and we are correcting the stock code anomalies. So let us find the number of unique stock codes and plot the top 10 frequent stock codes which are available here. So let's find the number of unique stock codes here using this code I'm stating here, and after let's find the top 10 frequent stock codes here. So which will tell us like what the stocks are in the top. So we will see. So what we can see from this data set is that is this frequent stock codes is like the product variety. So since the dataset contains 3,684 unique stock codes, indicating a substantial variety of products available on the online retailing, and we have the popular items available. We have the stock code. So we observe like most stock codes are composed of 5 or 6 characters, which are some anomalies like the post. So these anomalies may represent the services or non-product transactions here. So so let's find the numeric characters in each unique stock code. Okay. So you're finding the unique characters in the unique, sorry, numeric characters in the each unique stock codes. So for that purpose, what I'm doing is I'm taking a variable for the unique stock codes and df stock code. So we are getting the by using the unique function, I'm getting the unique data from those stock code, and after that I'm printing the value counts for unique stock codes. So here the output, what it is telling, the majority of the unique stop codes, that is 3676, that is out of 3684, contains exactly 5 numeric characters, which seems to be standard format, and there are 7 anomalies. So we can see here there are 7 anomalies, 7 stop codes which contains non-numeric characters, and one stop code contains only one numeric character, which clearly deviate from the standard format. So let's find and print the stop codes with zeros and ones in the numeric. So for that, what I'm doing is I'm taking anomalous stop codes in that one. I'm just getting the code here. I'm just running a loop here for the code in Unix stop codes, and inside the loop I'm using a condition, condition, if condition. So I'm just using this one, and I'm printing each stop code on the new line here. So finally, let's calculate the percentage of the records with this anomalous stop codes, and based on that we can see that the percentage of the records with anomalous stop codes in the data set is 0.48%. So based on this we can see, like, it is deviate from the typical format observed in the majority of the data, and these anomalous codes are just a fraction among all unique stop codes, that is only 8 out of 3684. So these codes also represent the non-product transactions of bank charges, post, everything. So so let's filter out and remove the rows with these anomalous stock codes from the data set, uh, for the better cleaning of the data set here. So I'm just removing those things here. So after that, I'm getting the number of rows, total number of rows in the data set. So now after removing those stock code data, our final number of rows in the data frames is 3,99,689. So now we are cleaning the description column. So in the description column, we are checking about the value counts. Okay, so value count, that is the most, okay, the top 30 most frequent descriptions we can see in this one here. And after doing that, we are finding the unique descriptions also. We're finding the unique descriptions by this code. So the unique description which contains the lowercase characters here are the bag, polysters, French blue. So these are the unique descriptions. So what we can say here is, like, it is like some entries are not product descriptions, like next day carriage and high resolution make. So these are unrelated to the actual products actually. So the step one, what we need to do is we have to remove the rows where description contains the service related information, like this next day carriage and high resolution image. And step two, what we are going to do is we are going to standardize the text to uppercase to maintain the uniformity across the data sets. So for that, we are getting the data is here. So we are using these two steps in this code. So first of all, we are calculating the percentage of the records with service related descriptions, and after that I'm printing the percentage of the records with service related descriptions, and then we are removing the rows with the service. So service related description, we are telling about next day carriage and high resolution images, what we are getting, which are not from uh, these descriptions properly. So I'm just removing them here. And finally I'm getting the rows in the data frame again. So let's treat the zero unit prices again. So we are treating the unit prices. We are getting a describe. So minimum unit value is the zero. This suggests that some transactions where the unit price is zero, it indicates that a free item or data entry error. That is, to understand this nature, it is very essential to investigate like these zero unit transactions, whether it is really a zero transaction, or is the detailed analysis product is needed here. So I'm just getting the quantity as well. So we can see that the transaction of the unit price of zero are relatively few in the number. There is only 33 transactions are available with zero. So these transactions have a large variability, and including these in the clustering analysis may introduce the noise and could potentially distort the customer behavior as well. Okay, so what we do is so we should remove these transactions from the data set. So this will help us to maintain a cleaner data set here. So I'm just sharing the code here. You can just simply run this code. In case if you're getting any difficulty in running this, you can just uh, send a message in the group, or else you can even ping me the Gmail. So finally, we are doing for the outlier treatment. So in KL, so in K-means clustering, since the algorithm is very sensitive to the scale of the data and the presence of the outliers, so they can influence the position of the centroids. So, which may impact for the cluster assignments as well. So we are to address this issue. So after the feature engineering phase, we are creating a customer-centric data sets. So so we are just resetting the index of the cleaned data set and getting the number of the rows again here. So now we are total number of the rows is 3,99,573. So the next one is the feature engineering. In the feature engineering, uh, we are using the RFM method. So RFM stands for recency, frequency, and monitoring. So recency is like basically how recently a customer has made a purchase. So low recency means the customer has purchased more recently. Frequency, this measures how often the customer makes a purchase within a certain period. A higher frequency value indicates a customer who interacts with the business more often. And a monetary, this metrics represents the total amount of money a customer has spent over a certain period. That is, customers who have a high monetary value have contributed more to the business, indicating their potential high lifetime value. So here we are calculating the recency. Okay, so first of what we do, we are converting invoice state to the date time type. Then we are converting the invoice state to date time and extracting only the date. And we are finding the most recent purchases date from the for each customer and finding the most recent date in entire data sets. After that, we are converting the invoice date to the data time type, and finally we are removing the invoice day column. So I'm just sending the code here. So now customer data frame contains only days since last purchase feature. So you can see. So now let's check again like customer data head. So what data we are getting over here. And finally frequencies. So frequency, we have two things. One is total transactions and another one is total products purchased. So total transactions represent like total number of transactions made by customer. So this will help us to understand the engagement level of the customer, like how far, like how frequently the customer is engaged with us. And total products purchased in this one, like some of the quantities, how many number of the products has been purchased. So these details can be seen in this. So for this, what we are doing here, we're calculating the total number of transactions for each customers, and the total number of products, new features, and first few rows of the customer data frame. We are looking on it. And next, you're looking on the monetary benefits by going to the total spends and the average transaction value. For that, again, we are calculating. We're grouping the data, and after that, we're calculating for the each customer here. And then product diversity, we are checking like how unique products have been purchased. So for that purpose, I'm just grouping the product using the customer ID and the stock code, and we are getting the unique products purchased, and we're getting customer data based on that. And next we have a behavioral features in which like average days between the purchases, favorite shopping hour, favorite shopping day. So this will help the companies to provide the offers or something. So if a company is providing some offer or making some special announcements, so it would be better like it should be uh, uh, like like main peak day of the week. Like for example, you could see like in the Big Bazaar and in many of the malls, they offer the discount. They offer the offers on the weekends only, because weekends will be the most like crowd will be attracted toward the malls, towards the purchasing places. So here we are just analyzing like what is the favorite shopping day of the week, favorite shopping hour. So we are merging the data in order to get the proper outcome out of it. Next, we are getting the geography features, like which country are having like which country the customer is belong to. So it will include the country data, which can help us to understand the region specific buying patterns and preferences. So for that purpose, I'm just using a value count here. And so here, first of all, we are grouping the data by customer ID and country. And next, again, we are getting the maximum number of transactions for each customers here. And after that, we are getting a binary. We are getting a binary column. Like for customer is from the UK or not, since the data set is from the UK, so it will more concentrate on the UK based. So they are checking like whether it is for the UK or not. Then we are merging the data with the customer data frame, and finally we are displaying some of the rows here by using the head method. Sorry, head function. So finally we are featuring the distribution here. And next, see the cancellation insights. So cancel insight, like let's check like the total number of transactions made by each customers, and so number of cancelled transactions, and we are replacing the NaN values, and finally displaying the first few rows. So in the same way, we are getting the seasonality, and we are checking the trend as well. And after that, we're changing the data type to the customer IDs. So these are everything going to the pre-processing only. And finally, we are again checking about the info here. So now we're treating the outliers in this. Percentage of inliners and outliers. So we are separating the outliners for the analysis in this code, and we are doing a correlation analysis here, like the total number of like by days of the week, by days of the hour. So correlation analysis will help us to get more insights about the data. And next, we are doing the feature scaling here in this code, and we are getting dimensionality reductions here. So here we have a like a cumulative variance versus the number of components. So we are converting the PC objects here, this code. So displaying the resulting data frames, and we are defining a function to highlight the top three absolute values for each column. And next we are doing a k-means clustering here. So that is ground truth clusters versus unexpected uh, clusters. So now we are going for the elbow method. So in the elbow method, so we have two methods, elbow method, silhouette method. So we are using the elbow method here for distortion score elbow versus k-means clustering. And we are also going to the silhouette analysis. So here we are getting some graphs for the silhouette analysis. So we are doing the k-means clustering here. We are displaying the first some rows, and we are doing the clustering evaluation, 3D visualization of the top principal elements. So we are showing the clusters here. So this is a 3D resolution. We can see like how the clusters are there, and cluster distribution we are visualizing here, and elevation matrix. Finally, cluster analysis. So cluster analysis, we are using a map here. Okay, we are using a radar chart. So using radar chart, so customer cluster 0 red chart, cluster 1 green chart, and cluster 2, it is for the transactions values. So it is a blue chart. So finally, we are using a histogram approach, like how many purchases have been done. So finally, we are segmenting the data here as per the stop code and the descriptions. Okay, so I have shared all the code in the group. Still, if you have any doubts, means you can just ping in the group, or else you can just you can simply ping on the group. Thank you. Any clarification or doubts you have? Anyone having difficulties for importing the data sets, importing the libraries? Okay. Okay. Then thank you. Still, if you have any doubts, you can just ping in. Thank you.